So congruent triangles, perimeter, and area. That's today's class. Okay, so to start with, let's start with what are congruent triangles. Okay, so congruent triangles, basically they're exactly the same, right? Just say your camera is on, it's just blared. You say you don't know why it is not working. Okay. So what is congruent triangles? Okay, so two triangles basically are congruent. If they're exactly the same, if you rotate them, they're still the same up to rotation. So for example, if it's very hard to rotate a triangle when you're drawing it, but if you draw this triangle again by rotating, and let's assume these are exactly the same triangles, you just rotated them, then they are called congruent triangles. Basically, they are exactly the same. They're up to rotation and also up to translation, which means you just move them around, and also reflection. And reflection then we say that two triangles are congruent. We will see examples and it will be more clear. Okay, so two triangles are congruent. We have different kinds of congruency. We have side congruency, which basically means if the three sides of two triangles are the same. So basically we just call it SSS. Okay, and then we also have side angle side, which we just call it SAS, and then similarly we have ASA, and then we also have angle side. Some of them are very easy. For example, angle side. Basically, if two angles are the same, then all angles are the same, right? And then remember that we don't have this. We do not have angle side. We do not have angle side. So if the angle side, we don't have angle side. This is very important. You remember it. We do not have, we do not have angle side. Okay, so let's just see some examples and then it is more clear. Before I give you examples for right triangles, right angles, if you have a right angle, then you can just look at hypotenuse leg or leg. Basically, it's hypotenuse leg or leg. Okay, leg basically, if the two legs are the same, basically it's going to be this one, right? Side angle side, because the two legs are the same and the angle between them is just 90 degrees. Or hypotenuse leg. So if any of this happens, then the two triangles are congruent triangles. Okay, let's go ahead without any delay. We look at some examples, okay? Okay, can I go to the next? I see some of you are taking notes. Wait. Let me know when you're done. Good. Okay. The header is taking notes. Header, are you done? Yeah. Okay. So let's just look at our first example of congruency. So it's very simple, but it's good to do warm-up questions. So we have A, B, C, D, E, F below. Okay, so let me draw it first. So we have the side. It's very symmetric. So A, D, B, this is the same as this one. This is the same as this one. And this is the same as this one. This angle is the same as this angle. Okay, so now let me write down the question. According to this, it's very clear what is equal to what. But let's just write down in A, B, C, D, E, F below. We know that AB is equal to AF. BC is equal to FE. CD is equal to DE. And the angle CDA is equal to the angle EDA. Now the question is asking you to prove that the angle ABC is equal to the angle AFE. Okay, so start please, everyone. Raise your hand if you're done. Rizi Chen, I don't know how to pronounce your name. Could you please turn on your camera? Jack West, I cannot see you. Thank you. Okay, I see one person is raising hand. Lucas, okay. Trevor, go ahead and tell me what did you do?
Oh, wait. I'm not sure if I made a mistake.
Hold on a second. My laptop is muted. Okay, can you talk now?
Yep.
Okay.
So I drew this lines.
Okay, let me draw it. Okay, so you want to join which one to which?
From C to E.
C to E. Okay. Hold on a second. Okay.
Two triangles that are congruent by SAS.
Which triangles?
Label the point between C and E, the intersection on line CE as G.
Okay.
GD and EGD are congruent by SAS.
SAS. Why? See how
GD is equal to DE angles.
they're sharing the same side, right?
Yeah, and they share side.
By SAS, and therefore they're congruent. Therefore, the corresponding angles are the same. Correct. Very good. So basically, SAS is one of the ways two triangles are the same. You don't really need to draw. Very good. It's correct. You may do it differently. You don't really need to draw a triangle here. We already have quite a lot of triangles, right? CDA. This is one way, which is very correct. Or you can draw another triangle, which I'm going to do it now. Another way is to draw this one. Still, it's the same. There I have these two angles sharing the side AD is equal to AD. And then CD equal to DE, right? This angle is, this side is equal to this side, and the corresponding angle, CDA, is equal to angle EDA. So therefore, by side angle side congruency, right? Side angle side, these two triangles CDA, we have to make sure we write down the vertices correctly. So we have to write correspondingly. So CDA, if I'm writing CDA for this, I have to write EDA for the other one. With the triangle EDA are congruent, right? This means if this is the sign of congruency, by the way, I didn't mention it, these two are congruent, and if the two triangles are congruent, then every corresponding angles are equal. In particular, the angle ABC what do we want to prove? We want to prove ABC is equal to AEF. Trevor, what did you prove?
Finish my solution.
So you proved ABC equal to AFE?
Yeah, I didn't finish that.
Oh, you didn't finish it. Oh, sorry, my mistake. I thought you finished it, and I thought. Okay, sorry, my mistake. Okay, so these two triangles are equal, and but these two triangles doesn't give me this triangle, right? So it's better to use to be able to prove that these two triangles are congruent. So since we already know that the CDA and these two are the same, what we can say is that their corresponding sides are also the same, which means AC is equal to AE, right? So we proved these two are equal, right? These two sides are equal. If these two sides are equal, I need to now prove these two are equal, right? So I can now look at their corresponding triangles, these two triangles, the triangle ABC, and is congruent to triangle AFE by what? Anyone? By? They are by side, right? They have exactly the same size by side, and therefore the angle ABC is equal to the angle AFE. Got it. Is it clear, everyone? Risi, are you here? Risi Chen, if you're here, turn on your camera, please. If you're not here, let me know if you're here. You need to turn on your camera all the time, okay? So it was not difficult, right? So we used side congruency. We also used side angle side. Remember, we do not have angle side. Okay. We also have leg and hypotenuse leg. Okay, so let's go to the next question. Okay, so let me please, if you need to take notes and I go fast, let me know. I can wait for you to take notes. Okay. So let's do the next one. We have, okay. not difficult. So let's say we have this triangle ABC is an equilateral triangle. It's very hard. This one I remember is very hard to draw, but I will try my best. Let me draw this first. Okay. It's a rough graph, so A, B, C. I think I'm good now. Okay, triangle ABC is equilateral. And then ABC, ABDE, this one, ABDE, ABD, BCF, BCFG, and the other one, CA, this one, AH, can't read my writing, this is I, AHIC. These three are squares. Basically, this means basically everything is all sides are almost all sides are equal. Are squares. Prove that triangle DFH oops. DFH is equilateral. Okay? 1 minute, everyone. Try your best. Okay, so anyone who wants to do it? Okay, so let's go ahead. Because of the time, I have to start doing this because of the time. So it's a little bit more involved here. So I'm just going to go slowly and explain this. So first of all, okay, so all these, because this is an equilateral triangle and these are all squares, so all these sides are equal, right? So basically, prove we know simple CA, which is this one, B equal to AB, equal to BC, equal to all of the other ones, right? CA, okay, so the ones that I really needed, let me just write down those ones. CA is equal to AH, A equal to AB, right? And equal to BD, equal to BC, equal to CF. Right? These are all the same because this is a equilateral triangle and these are all squares. So the angle CAH obviously is 90, right? The angle CAH, ABD, the angle ABD, and the angle BCF, they're all 90 degrees, right? So this means that the triangles CAH, this is just basically, I want to prove that the diagonals of these squares are the same, which seems to be obvious if you use Pythagorean theorem, but we haven't learned it yet. Let's assume we haven't learned it. So we want to prove that this CH is equal to the other one. Okay, CH is equal to BF. They're all the same. We know that, but let's just prove it by using triangle similarity. So the triangle CAH is similar to the triangle ABD and is similar to triangle BCF, right? And therefore, their corresponding sides are the same. So which means basically AD is equal to, the diagonal of the squares are the same. AD equal to BF equal to CH, right? So far so good. So we have this one. Now I want to look at the angle, this angle. I want to look at the angle EAH. The angle EAH is obviously 360 minus, this is 90. This is 90, right? Let me use another color. This is 90. This is 90. So it's 360 minus 90, obviously minus 90. And this is equilateral triangle, so its angle is 60, right? This is 60, this is 60, this is 60. So it's minus 60, which is basically 120. So the angle EAH is 120. And the angle DAE, the angle DAE let me just make sure I'm doing it correctly. The angle DAE, because this is basically the DA is the diagonal of this triangle. Okay, so Heather asking me a question. Heather, they are technically not triangles, so they aren't actually equilaterals. Why? ABD is a triangle. Why equilateral? Which one are you talking about? CAH is a triangle, right? CAH. I did not join them. If you want, you can join them, right? I did not join it. I just used it. CAH, right? ABD. So basically, I did not join them. So you can just join these diagonals, right? BCF. So basically, it's, I mean, this one, right? Okay, got it? All right. So sometimes we don't draw them, but when you use the vertex, three different points, then it's going to give you a triangle, right? Okay. So the angle DAE, which is this one, obviously is 44 degree. Again, you may say why? because it's the square and the diagonal of square basically divides the angle into two. If you don't understand that way, you can just think of the angle DEA. It's an isosceles triangle, and this is 90 degrees. Therefore, this is 45. This is 45, right? In an isosceles triangle, we have 45 degrees. So this is also 45 degree, the angle DAE. Now let's look at the angle DAH. DAH. So the angle DAH is the angle, obviously it's the angle DAE, which is on 45 degree, and then plus the angle EAH we just found. So it's 45 plus 120, so it's 165 degrees. So the angle DAH is 165 degree. Okay, so this shape is very symmetric, kind of symmetric somehow. If you look at it this way, if whatever happened to this side, this vertex A, similar thing happened to the vertex B and also to the vertex C, right? We can similarly say the same thing. So similarly, the angle FBD, similar to this one, the angle FBD is also 100. We proved DAH is 165. The angle FBD, exactly similarly, you can prove is equal to the angle HCF, and they're all equal to 165. HCF. Okay, good. So why I'm doing this? So now I have something to say. I can look at three triangles. The triangle DAH, triangle FBD, and triangle HCF. DAH. This is one triangle here. We have HCF, these small triangles. They're very narrow, small triangles, right? These three triangles are actually congruent. Why? They have the same sides, CH, which are the diameters, right? And these are by side, angle, side. They have the same side, the diameter, right? And then this CF, right? This one of the sides are the diameter of the squares. The other side is the side of the side length of the square, right? And then the angle that we just proved, they're all 165. So they are congruent triangles. And this basically implies that their corresponding sides are equal, which means DF is equal to FH equal to HD, right? So we are done. So that's what we wanted to prove. We wanted to prove that all these sides are equal. In other words, this big triangle DHF is an equilateral triangle. Is it clear, everybody? If you don't understand any part, please ask, okay? Okay, so let's go to the next question. Okay, again, if you need to take notes, just tell me. Okay, next question. Okay, so I have a question here. Trevor, you can always talk, okay? So you can talk to me. If you can say that FBD, and HCF are equal to DFB. Just make sure HBD, HCF. HCF, the same angles are equal by symmetry. Can you just say that all the angles in the triangle DHF have the same angles by symmetry? Yeah, they have the same angles by symmetry.
Because if they have the same angle, then they're equilateral.
But how do you use the symmetry here? I don't understand how do you use the symmetry.
Because the argument here is that so DAH, FBD, and HCF have can have the exact same steps done to them to get the same angles. So then, from point D, H, and F, it's symmetrical on all sides. There's no difference if D is on the bottom, F is on the bottom, or H is on the bottom. Right?
Yeah, but you have to tell me why there is symmetry. There is such symmetry here, right?
But
if that's the case, you can just say they are equal. They have equal sides, right?
Yeah. Okay.
You got the point, right?
Yeah.
So now let's do another one. I'm going to write down the question again. So this time, you see, most of the times when you are doing a triangle congruency, usually triangles are sharing sides, usually, not always. And this is one of them. In the diagram below, what's the diagram? Anyway, in the diagram below, the angle x, y, z equal to the angle ax, z equal to 90 degree. Let me draw this diagram first. This graph. So we have a right triangle. And then all right. Okay, so this is x, this is b, this is y, this is 90 degree, this is 90 degree, this is a, and this is z. So the angle x, y, z is equal to the angle ax, z, 90 degree. And the angle and ax is equal to xy, even though my shape doesn't show it. And the angle xzd, which is basically this angle, is equal to the angle yzd. Okay, so now the question is asking you to prove that ZD is perpendicular to a ZD is perpendicular to a Y. Okay? Try it, everyone. I'm going to call, this is not part of the question, but those be written in another color other than green are not B here, and I'm going to call this one C. Okay, try it. 1 minute. Okay, so anyone got the answer? Okay. So again, time, we have to do it together. Let's do it. So I call this A. So I'm going to write down something and you tell me why that's the case, okay? So proof. To prove that ZD is perpendicular to AY, it is enough to show that triangle ZCB is congruent to triangle ZCY. Can anyone tell me why that's enough? Darren?
Because basically we're trying to prove that BZY is an isosceles triangle. So if we know that it's an isosceles triangle, we know for sure that it has to be a right angle.
BZY is an isosceles. Why? Again, I don't understand. If it is an isosceles, I don't say it's isosceles.
Because angle BCY is a 180-degree angle, so if...
Exactly, because this is a straight line. AY is a straight line segment, right? So if the angle, basically I'm writing here, ZCB is equal to the angle ZCY, it's going to be, this is a straight line, so it's going to be 180 divided by 2, right? Right? AY is a straight line. So it's, so this is a straight line. So this angle plus this angle equal to 180, and the other hand they are equal, so they will divide by 2. Everyone is it clear what we said? Okay, good. If you don't understand, please ask. Good. Now let's try to prove, in fact, that these two triangles are congruent, and then we are done. So how to prove these two triangles are congruent? So let's look at this the information that is given to us, right? We know that AX is equal to XY, right? So AX is equal to XY, right? And then the angle XYA, the angle XYA. Let's look at this angle. So this means this is an isosceles triangle. So the triangle XAY is isosceles, right? And this means that the angle XYA is equal to the angle A, right? Is it clear, everyone? This is equal to an angle A because it's an isosceles triangle. And the angle ABX, let's look at the angle ABX. The angle ABX, because this is 90-degree triangle, this triangle ABX is right triangle, is obviously 90 minus the angle A, right? And the angle ZYC, let's look at the angle ZYC. The angle ZYC is the angle ZYX, right? ZYC is the angle ZYX, which is basically 90-degree, minus the angle, I'm looking at basically this one, ZYC, is equal to the angle ZYX minus the angle AYX, right? I just look at this angle. This angle is equal to the whole angle minus this angle, right? So basically this is 90, but the angle AYX is, according to this triangle, the angle AYX, which is basically this angle, according to this, is exactly the angle A, right? So now what we have proved that the angle ZYC is equal to the angle minus 90 minus the angle A, right? So this is 1, this is 2. Look at it. So the angle ABX, the angle ABX is 90 minus the angle A, right? The angle ZYC is also 90 minus the angle A. So now let's look at the angle ZBC. The angle ZBC is equal to the angle ZYC, right? So because they're the same, right? I should just put this one, right? The angle ZYC is 90 minus the angle A. The angle ZYC is, where is it? ZYC is 90 minus the angle A. The angle ZBC is also 90 minus the angle A, right? They prove it. So the angle ZBC basically is the angle ABX, right? The angle ZBC is equal to the angle ABX, because these are the same, right? And the angle ABX is 90 minus the angle A. If you want to be more clear, just write it this way. So we call this one now 1 and the 2. From 1 and 2, the angles ZYC and ZBC are the same. So these two angles are the same. And how about the angle YZC? The angle YZC, according to the question itself, it says the angle YZC is equal to the angle BZC. Question gave us, right? Right? These two angles are the same. No, we proved ZBC and ZYC are the same, right? So this means that triangle ZBC is congruent to triangle ZYC by angle, side. Right? Angle, side, because they are sharing the same side, ZC, right? We have angle, you guys remember triangle similarity, we also have angle, side. So by angle, side, angle, and side, they are similar, and we are done. So we proved these two triangles are congruent, and therefore their corresponding angles, this is 90, and we are done. Any questions? Okay. The next topic we want to cover when we deal with congruency and also triangles is perimeter and areas, how they are related, if they have some relation between their height and base. That's the next topic. To start the next topic, let's go for 10 minutes break, okay? See you in 10 minutes.